Let's continue with next data, that is raster data. So I call raster data as a grid-based view of the world. Why? Because raster data provides a continuous representation of a geographical space, much like a digital photograph. So if I want to define a raster data, I will use the word as it is a data which is composed of grid of cells, or I can define it as it is a data which is having pixels which are arranged in terms of rows and columns. Each of these pixels have a specific value that represent a characteristics of that location, such as elevation, temperature, or land cover. So these size of pixels determines the spatial resolution of the data. So there are types of raster data. One are continuous raster, another one is discrete raster. Continuous raster represents the phenomena that gradually keeps on changing over a surface. For example, your digital elevation model showing the terrains and height. Your temperature maps can show different types of analysis. Same way as NDVI. So based on your satellite images on various times, and if you are having a continuous raster, you can feature all those things in a proper visualization. Next comes the discrete raster. This represents a categorical data. So what does it do? Where each pixel value corresponds to a specific class. You can use it as a land use maps where we can go for supervised and unsupervised. So we are categorizing a particular pixel value to a particular class. So it can be different in terms of urban or built up or forest or soil type based on that. So this is a district raster. There are different standards to save this raster files, out of which are three most famous one are GeoTIFF file. Its extension starts with TIF or .tiff. Next, JPEG form of 2000 and ESRI product. So ESRI CRID. So this GeoTIFF and JPEG, these are widely used based on different need and necessity. So a GeoTIFF file automatically is most commonly used because it has lot of informations based on locations or sources. So it has a complete set. But when it comes to JPEG, we need to georeferencing it. So we need to save that image and then later we have to georeference it. And ESRI Grid, it's one of the product that is developed by ESRI developers. So let us understand GeoTIFF and what is different types of capabilities that we are doing it. So as I was saying something about georeferencing, this helps us to identify a particular image when we are including a spatial metadata to coordinate it to the lat and long, or give a map which is having a projection. So there is such an tool that is available or feature in GIS or any software, that is coordinate reference system. So this georeferencing will help us to include the spatial metadata with the precise geographical locations for each image pixels. TIFF based is some characteristics of GeoTIFF, which is nothing but a tagged imaged file format. So this helps us to ensure the capability of a standard image in terms of viewing it into a software which is having a geospatial capabilities. Unlike some other spatial formats, the embedded metadata sets separate the sidecar files. So GeoTIFF file embeds all the necessary informations based on locations and projection data. So then they are going to use it as a special tag or TIFF file. Next comes our raster data. This raster data is also used to store as a pixel based data in GeoTIFF, making them ideal representation of the real world. Your example is digital elevation model, land cover, or temperature. So multi-band capabilities are also, they are using it in terms of multiple layers within a single file, or bands, satellite bands, and so they have been used. So GeoTIFF are a industry aligned saving profile. They have been used in QGIS or RGS. They allow the users to add georeference image map layers directly into the global regional map. So their examples can be drone mapping, where they use GeoTIFF file to store the images, digital elevations. They provide accurate image positioning based on surveying and mapping. Then They can be used by many government agencies and researchers. They use to analyze satellite imagery and other science data. For example, earth science data is based on precipitations and various applications. So all these things can be saved in geotiff file. So these are having coordinate systems. They are very much useful for giving us a map projections, what type of spatial extent it will go, and so on. So this is about geotiff file. Another one is ESRI. So ESRI is nothing but one of the products. This has been developed by ESRI, a huge company or developers. They have made this into a accessible format where it is allowing two types of formats. One is ARC Info Grid, and another one is ARC Info AS CII grid. So they have many variations. So what does this ESRI grid does? It divides an area into a grid of cells or pixels, which is different from vector data that uses point lines and polygons. These work on cell based values. They identify each cell with a single numerical values, and they represent the characteristics based on the location. They can help us to store and sometimes integrate floating point values and help us to integrate these values in terms of continuous data also. So you may be wondering what is ASCII grid. It is a non-proprietary format designed to data exchange. Usually CSV files and all this comes into this. Their applications are more. ESRI grids applications are more. They're used in spatial modeling. They can use in identifying the slopes, flows of a particular surface, and so on. So binary grids are something which we can store a primary storage, and these are used in different types of ESRI software. Next comes this. So now you can able to identify what we mean by vector as well as raster. So as you can see, there are point, line, and polygon features. Here everything is in pixel bit. So why we have these two types? So when we are integrating these two things, they represent different objects. For example, if you take a road network at your place, so it has a property, boundaries, neighborhood. So in order to save all those things, we can combine these two things. So we can use raster to show a particular school or area photograph of a school, or a map, a rainfall map, elevation, mountain range, because all this together makes the analysis more easy. And remember, every one of these vector shapes or raster pixel can have a non-spatial attribute for a data to it. That means that a line of a map is just not a line. It can be a particular road, a line on a particular place. You're coming back to a college, probably that road. So a certain length, a certain speed limit, all these things which gives us an understanding where and what in a beautiful manner, in an attributed manner, in a visually appealing manner, and with this information can be done into more complex modeling. So yes, that where and with the what together, they form the importance of this GIS. So that's why spatial and non-spatial, even vector and raster, these all hold an important role in GIS. So once when you understand your research or your identification or objective to do a particular study, so you should know what type of data set you are having, how you are going to incorporate it, and how you are going to analyze. So even you can change vector to raster format and raster to vector format based on your things. If you are going for land use mapping from a vector image to a, then you have to merge, clip, mosaic. There are so many other things. So this gives you an idea. This gives you an idea how to use them. So that is the true power of GIS. It connects the where with the what. So I hope you have understood much today, and would have helped you. So thank you so much. So with this, there are more evolving GIS database. So beyond the basics, we can see 3D or volumetric data. These are having a lot of powers, and it has grown into a larger extent, and it has the ability to represent and analyze the world in 3 dimensions. So the basic definitions are this: 3D datas have a vertical component, that is Z, and to the traditional 2D spatial data, this allows a representation of height and depth. So this volumetric data takes these steps further by presenting the phenomena of 3D grid or wall X or volumetric pixels. For example, a building model with a height, this extrudes the polygons. So 3D utility networks. Then you are having 3D raster, where you can go with subsurface geological models, atmospheric pollution plumes, or oceanographic data based on temperature, salinity, a particular image, a coral reef, a particular animal. All these things can have a meaning over here. So the standard formats for this 3D and volumetric data are CTGML. This is an open standard for representing a 3D urban objects such as LAS, that is laser, and LAS, that is compressed LAS. So they are all formats for storing leader point cloud data. So there are other few also time series and spatial temporal data sets where recognizing the world is not statics now. So GIS has now increasingly incorporated dimension of time. So this is nothing but we are involving the track of movement of the objects attributed based on specific locations. For example, you can track the path of a hurricane. You can monitor changes in the land use over several decades using satellite image. You can analyze the spread of particular disease through population over time. So there are many formats you can save this time series and spatial temporal. So, one of the most common is network common data form, that is netcdf. So these are the set of software libraries for self describing machine independent data format. So they create those creations, access, and they share area array oriented scientific data, which are often used for temporal data sets. So all these are processed. So not only vector data and raster data, now we have moved forward. So only to have an ability to understand and to visualize, to understand complex analysis and relation, to predict and forecast, all these things hold an important note in remote sensing and GIS. So I hope this has helped you. Thank you.